For decades, I have dedicated my theoretical work to exploring a single radical question. Is the universe we see with our eyes and measure with our telescopes all that exists? Or are we floating on a thin, three-dimensional sheet inside a far grander multidimensional cosmos, deep beneath the serene countryside, along the border of France and Switzerland, inside a 17-ring of powerful superconducting magnets? The Large Hadron Collider at CERN smashes subatomic particles together at speeds agonizingly close to the speed of light. The primary goal has always been to recreate the extreme conditions of the early universe and reveal the fundamental building blocks of matter. But recently, subnomies in the data from these ultra-high energy collisions have pointed towards something far more astonishing than just a new particle. And during these violent subatomic impacts, measurable amounts of energy appear to simply vanish into thin air. Yet, according to the most bedrock walls of physics, energy can never be destroyed. It must go somewhere. And the mathematical evidence hints at a mind-bending possibility that energy is leaking out of our familiar three spatial dimensions and escaping into hidden microscopic extra dimensions curled up right beneath our noses. Before we unravel the extraordinary mechanics of this phenomenon, take a brief moment to subscribe to the channel and join our community as we explore the deepest mysteries of space and time. If these missing energy signatures are what some of us suspect, CERN may have accidentally crossed a monumental scientific frontier. We may not just be uncovering new physics. We may be catching our very first glimpse of a hidden realm, proving that our universe is far larger, richer, and stranger than we ever imagined. To truly grasp the magnitude of what the data from CERN might be telling us, we first have to take a step back and examine the very fabric of the reality we navigate every single day. Look around you. Everything you have ever touched, every place you have ever been, and every star you have ever looked up at exists within a framework that feels entirely absolute to human common sense. We live in a universe defined by three spatial dimensions. You can move left and right, you can step forward and backward, and you can climb up and down. So these three directions of motion are the stage upon which the entire drama of human history and seemingly the universe has played out. For thousands of years, we assumed this was the end of the story. Our brains evolved to hunt, to gather, and to build on the surface of a three-dimensional rock. We never needed to perceive the universe at the microscopic quantum level, nor at the immense cosmic scale. Because of this, our intuition is severely limited. Our common sense is a localized bias, but modern physics has taught me and my colleagues a profoundly humbling lesson. Human intuition is a terrible guide to the true nature of reality, and to understand how an entire dimension could be hidden from your view right in front of your eyes, I want you to imagine a long, heavy cable, perhaps a power line, stretching across an empty highway against a setting sun. If you are standing a mile away looking at that cable, it appears to your eyes as a perfectly one-dimensional object. It only has length, and you can point to a spot on the left or a spot on the right. From that distance, there is no other feature to describe. But suppose you walk toward that cable, you get closer and closer until you are standing right underneath it. Now imagine you have the eyes of a tiny ant walking along the surface of that wire. The ant experiences a completely different reality than you did from a mile away. The ant can walk forward and backward along the length of the cable, but it can also walk clockwise and counterclockwise around the circular girth of the cable. What looked like a one-dimensional line to a distant observer actually has a second curled-up dimension that only reveals itself when you get close enough. This simple shift in perspective is the foundation of one of the most powerful ideas in theoretical physics. Back in the 1920s, brilliant thinkers like Theodore Kuza and Oster Klein realized that this exact same principle could apply to the fabric of space itself. We look at the space around us and see only three dimensions. But what if there are other dimensions, extra dimensions, that are curled up so tightly and are so incredibly microscopic that we simply cannot see them? I am not talking about parallel universes or alternate timelines. I am talking about literal physical directions in space, directions you could point to if only your finger were small enough. So imagine that at every single point in the space around you right now, as you listen to my voice, there are tiny extra dimensions curled up into complex microscopic shapes. Because these dimensions are billionth of a billionth of the size of a single atom. You cannot feel them, and you cannot move through them. A car on the highway or a planet orbiting a star only moves through the 3 large M extended dimensions. But to a fundamental particle like an electron or a photon, these microscopic dimensions are very real. They are the hidden terrain of the quantum world. And this is where the Large Hadron Collider enters our story. We cannot use magnifying glasses or traditional microscopes to see these tiny dimensions. The only way to probe the fabric of space at that unimaginably small scale is to smash particles together with violent, staggering amounts of energy. We use energy as our microscope, and what we are looking for is a crack in the foundation, a signature that shows a particle suddenly slipped into one of and those hidden crevices of reality. So, how exactly do we use the Large Hadron Collider to search for something we cannot even see? When we accelerate protons to 99.999% of the speed of light and smash them head-on, we are creating a miniature, highly concentrated fireball of pure energy. And from that burst of energy, new subatomic particles are born. Inside the control rooms, we have detectors that are essentially digital cameras the size of cathedrals. They track the trajectory, speed, and mass of every single piece of debris that flies out of that collision. According to the bedrock law of conservation of energy, if you add up all the energy and mass that goes into the collision, it must exactly equal all the energy and mass that comes out. The accounting books must balance perfectly, and there is 0 exceptions. But what happens when they do not? What happens when our supercomputers do the math and a fraction of the energy is simply gone? It is like rolling 2 billiard balls together at 10 miles per hour, and after they collide, they slowly drift apart at 1 mile per hour. Where did the momentum go in our standard 3-dimensional space? A vanishing act like this is a blatant violation of the laws of physics. This missing energy is not a sign that our machines are broken. It is the signature of a ghost. And this brings me to one of the most embarrassing secrets in modern physics. I want you to think about gravity. It feels incredibly strong when you try to jump off the ground or when you carry heavy boxes up a flight of stairs, but the absolute truth is, gravity is pathetically weak. Let me prove it to you right now. Think about a simple refrigerator magnet. The entire Earth, a massive sphere of rock and iron weighing roughly 6 trillion kilograms, is using all of his gravitational might to pull a small metal paperclip to the floor. Yet, a tiny cheap magnet the size of a coin can reach down and pull that paperclip right up into the air. A tiny piece of magnetic metal effortlessly defeats the gravitational pull of an entire planet. Electromagnetism is roughly a billion times stronger than gravity. For decades, my colleagues and I have asked ourselves why is gravity so incredibly diluted compared to the other fundamental forces of nature? The mathematics of string theory, the framework I've spent my life studying, offers a brilliant and elegant solution. It suggests that gravity is not actually weak. Instead, gravity is the only force that is not confined to our 3 dimensions, while light, magnetism, and the nuclear forces are permanently glued to our 3-dimensional sheet. Gravity is free to leak out into the extra dimension. Imagine you are standing in a large open field speaking to a friend. If all your sound waves were channeled through a tight solid tube directly into your friend's ear, your voice would sound intensely loud and clear. But if you take away the tube, the sound waves spread out in all directions into the open air. By the time the sound reaches your friend, it sounds incredibly faint. We believe gravity is spreading out into those curled up microscopic dimensions we talked about earlier. So we only experience a tiny remnant of gravity's true strength because the vast majority of it has spilled over into a hidden geometry. And this is exactly what we are hunting for in the data at CERN. During those violent subatomic collisions, we are looking for a heavy force carrying particle of gravity known as a graviton. We believe that for a fleeting fraction of a second, the collision produces a graviton, and that graviton immediately escapes. It vanishes into an extra dimension, taking a small chunk of energy with it. When our detectors register that missing energy, we are not just finding a mathematical error. We are watching a particle step through a doorway into another realm. Listen to me closely. The reality you experience every single day hides a terrifying and fascinating secret. We have established that energy is vanishing inside the particle accelerators at CERN, and we suspect it is leaking into extra microscopic dimensions. But the moment you accept this possibility, you are immediately confronted with a profound and unsettling paradox. It is a paradox that shatters our most basic understanding of distance, separation, and the structure of the cosmos. To understand this paradox, we must first look at a fundamental fact of our existence. We inherently trust the concept of distance. If you want to travel from your home to a grocery store, you have to cross a specific amount of space. If you throw a baseball to a friend across a wide field, that ball must physically traverse every single inch of the air between you. We view space as a rigid, empty container. It provides a fixed separation between objects. This absolute separation keeps our world predictable and safe. It ensures that things far away cannot instantly affect us without first crossing the void. But if the fabric of reality contains hidden folded dimensions where particles of gravity can roam, that rigid container is a complete illusion. The separation between objects is not what it seems. I want you to think about an old-fashioned paper road map, the kind you might have unfolded across the dashboard of a car during a long summer road trip decades ago. Imagine tracing a route from New York to Los Angeles on that flat two-dimensional sheet of paper. The distance is vast. An ant walking across the map has to tirelessly march across every inch of the paper to get from one coast to the other. That ant represents us. It represents our entirely three-dimensional view of the universe. Now, imagine taking that map and folding it perfectly in half. Suddenly, the dot for New York and the dot for Los Angeles are touching back to back. If you had a needle, you could pierce a hole straight through both cities at exactly the same time. If the ant saw you do this, it would be completely baffled. And from its perspective, trapped on the surface of the paper, you just traveled an immense distance instantaneously. But you did not move faster than the end. You simply stepped into a higher dimension. You moved through the space above the flat paper, bypassing the traditional distance entirely. At the quantum level, the extra dimensions predicted by string theory act exactly like the folds in that roadmap. Space is not a flat, rigid container. It is complex, folded, and woven together in ways our minds struggle to picture. When a graviton is created in a Billing collision at CERN and suddenly vanishes, it does not cease to exist. It simply steps off the flat paper of our reality. It enters the folds. It takes the shortcut. And here is where the paradox strikes. In the strict laws of physics, every doorway swings both ways. If a particle of gravity can leak out of our three-dimensional space and slip into a higher dimension, the rigid laws of quantum mechanics demand reciprocity. Energy from that hidden realm, that higher dimensional space, should theoretically be able to leak back into our world. We have spent our entire human history believing our universe is a closed, secure, and isolated system. We believed the walls of our reality were impenetrable. But the missing energy itself suggests our reality is porous. It is like a sponge. If a microscopic particle can slip through the cracks, it means our universe is constantly interacting with a realm we cannot see, cannot feel, and barely have the mathematics to describe. If gravity is bleeding out, we are forced to confront a staggering question. What exactly is bleeding in? Are there forces or perhaps even structures residing in those microscopic folds that are quietly influencing our universe right under our noses? And the paradox is that the closer we look at the smallest building blocks of matter, the more we realize our vast, sprawling universe might just be a tiny, porous membrane floating in a much grander ocean. I want you to clear your mind of everything you think you know about the structure of reality. We've talked about energy leaking out of our particle accelerators. We have talked about gravity spilling into hidden microscopic folds in the fabric of space. But now we're going to take that concept and push it to its absolute terrifying and all-inspiring logical conclusion. Prepare yourself, because this is the moment where human intuition completely breaks down. In the advanced mathematics of string theory, we encounter a concept known as a membrane, or simply a brain. A brain is essentially a slice of space. A two-dimensional brain would be like a flat sheet of paper. But our universe, the reality you and I experience every day, appears to be a three-dimensional brain. We are living our entire lives on a three-dimensional surface that is floating inside a much larger, higher-dimensional space that physicists call the bulk. To visualize this, imagine a long loaf of sliced bread. Every individual slice of bread represents an entire three-dimensional universe, complete with its own stars, planets, and galaxies. Our universe is just one single slice in that immense cosmic loaf. And just like a slice of bread, our universe has neighbors. Now, recall what I said earlier about the fundamental forces of nature. Electromagnetism, which includes visible light, is permanently glued to our specific slice of bread. When you turn on a flashlight, the light cannot leave our universe. It is trapped on a surface. This is why when you look up into the night sky, you only see the stars that belong to our slice. You are blind to everything else. But gravity is profoundly different. Gravity is not glued down. Gravity is the only force capable of rippling through the higher dimensions, moving freely across the gap from one slice of bread to another. And this single mathematical property provides a breathtaking answer to the greatest unsolved mystery in modern astronomy. For nearly a century, astronomers have been haunted by something we call dark matter. When we look at how fast entire galaxies spin, the laws of classical physics tell us they should fly apart into the void. There is not nearly enough visible matter, not enough stars or planets to hold them together. In fact, 85% of the mass in our universe is completely invisible. It emits no light, it reflects no light, yet it exerts a massive gravitational pull that keeps our galaxy intact. We have spent decades building highly sensitive detectors deep underground, hoping to catch a rare, exotic dark matter particle floating through our world. We have found absolutely nothing. But what if we are looking in the wrong place entirely? What if the reason we cannot find dark matter in our universe is because it is not in our universe at all? Think about living in an old, densely packed apartment building. Imagine your apartment has perfectly soundproof, windowless walls. You are completely isolated. You cannot hear your neighbors and you cannot see them. But suppose the neighbor directly above you drops a heavy cast iron safe onto the floor. Even though you cannot see the safe, you will physically feel the heavy vibration shake your own ceiling. If you had absolutely no idea that other apartments existed above you, you would be utterly baffled. You would think there was some invisible phantom force inside your own room shaking the walls. You would measure its force, and you would call it dark matter. This is the mind-breaking truth that the mathematics at CERN might eventually reveal. When our telescopes detect the immense gravitational pull of dark matter, we might not be looking at a cloud of invisible particles. We might be feeling the gravitational echo of an entirely different universe hovering a microscopic fraction of a millimeter away from our own in a higher dimension. The dark matter holding the Milky Way galaxy together might actually be the gravitational shadow of a massive parallel galaxy on the adjacent slice of bread. There could be parallel stars, parallel planets, and perhaps even parallel life forms existing right next to us. They could be occupying the exact same space that you are sitting in right now, separated only by a microscopic distance in a fourth spatial direction. You cannot point to, you cannot see them because their light is trapped in their world, but you can feel their immense weight pressing against the fabric of our reality. And the universe we see with our eyes is not the whole story. It is merely one page in an infinitely thick book. We have journeyed through the mind-bending landscapes of string theory, visualizing extra dimensions, microscopic phos, and parallel universes stacked closely together like slices of bread. It is a stunning, elegant framework. It solves the mystery of why gravity is so weak. It offers a profound logical explanation for the phantom weight of dark matter. But as a physicist, I must bring us back from the soaring heights of mathematical theory and drop us onto the cold concrete floors of the experimental control rooms. And here is the hard, uncomfortable truth. Mathematics, no matter how beautiful or perfectly balanced, is not reality until it is proven by physical evidence. We have been protons at the Large Hadron Collider for years. We have smashed them together billions of times per second. We are looking for that tiny, fleeting deficit of energy. We are hunting for a whisper of a graviton escaping into the bulk. But finding that signature is like standing in the middle of a roaring hurricane, deafened by the thunder and the wind, and trying to listen for the sound of a single pin dropping onto the wet grass. Let me give you a sense of the sheer scale of this challenge. A single collision event at CERN produces a chaotic shower of hundreds of ordinary subatomic particles. Quarks, gluons, muons, and photons spray outward in every possible direction. It is a blinding flash of quantum shrapnel. Our supercomputers have to sift through a torrential downpour of digital information, reconstructing the exact path and energy of every single spark of matter just to see if the accounting ledger comes up short. We are looking for a phantom thief in a chaotic crowd of billions. And while we have seen tantalizing fluctuations, those whispers in the dark, where a fraction of energy seems unaccounted for, they have not yet crossed a rigorous threshold of absolute scientific certainty. The hard truth is that in experimental physics, a hint is not a discovery. Until we have unquestionable, undeniable statistical proof, the escaping graviton remains a mathematical ghost. This lack of absolute proof forces us to confront a sobering possibility about the limits of human capability. What if our tools are simply too blunt? The Large Hadron Collider is the absolute pinnacle of human engineering, but on the cosmic scale, it is barely a spark. If these extra dimensions are curled up tighter than our most optimistic estimates, the energy required to pry them open, to force a particle across the dimensional threshold, is staggeringly high. It would be like trying to crack open a massive steel bank vault with a plastic spoon. To truly access the bulk, to routinely send particles into the higher dimensions and measure their return, we might need a machine that encircles the entire Earth. We might need a Parco accelerator that spans the distance from the Earth to the Moon. And that is the ultimate hard truth we must face as a species. There is no guarantee that the universe owes us an explanation that fits neatly within our current technological reach. We are biological creatures trapped on a tiny rock, bound by our three dimensions, trying to peel back the curtain on the fundamental architecture of the cosmos. The mathematics tells me that these higher dimensions must exist. The equations demand them, but the universe might have hidden them at a scale so unimaginably small, or requires energy so unfathomably large that we may never fully cross the threshold. Does that mean we have failed? Does that mean the pursuit is pointless? Absolutely not, because the pursuit itself has fundamentally changed who we are. Every time we push our machines to the absolute limit, we learn more about the fabric of reality. We rule out the impossible. We narrow the hiding places of the universe. The hard truth is that we are imprisoned by our own dimensions. But we are a species that has figured out how to see the bars of the cage. We know where the doorway is. Now we just have to figure out how to turn the handle. I want you to imagine the day it finally happens. Imagine a Tuesday morning, years from now, when the supercomputers at CERN finish crunching the data from a new unprecedented run of high-energy collisions. The physicists gather around the monitors. They check the calculations once, twice, 100 times. But there is no error. A massive, undeniable deficit of energy has been recorded. It has passed the gold standard of absolute statistical certainty. On that day, humanity will have caught its first verified graviton slipping through the cracks of our reality. In that single quiet moment, the entire human paradigm will shatter and reform. It will be the greatest scientific revolution since we realize the Earth revolves around the sun. Because the moment we prove that a particle has entered a higher dimension, we are forced to accept that our entire three-dimensional universe is just a single membrane floating in an unimaginably vast higher dimensional void. And this realization leads us to the ultimate climax of string theory. It leads us to the true origin of everything. For decades, we have said that our universe began with the Big Bang, a microscopic point of infinite density that violently expanded from absolutely nothing. But frankly, that has never been a satisfying answer. It feels deeply incomplete. Where did that initial seed come from? What actually triggered the expansion? If our universe is a flat sheet floating in a higher dimensional space, then it is not alone. As we discussed, there are other sheets, other brains rippling and moving through that hidden void. Now, I want you to visualize two massive parallel sheets floating very close to one another in the dark. Over billions of years, the gravitational pull between them draws them closer and closer together. They accelerate, they ripple, and eventually they violently collide. When two immensely massive energetic universes slam together in a higher dimension, the kinetic energy of that impact is utterly incomprehensible. That colossal collision would instantly spark a raging inferno of energy and radiation across the entire surface of the brains. To anyone living on the inside of that membrane, that explosive spark of heat and light would look exactly like the Big Bang. The profound implication is that our beginning was not a unique magical creation out of the void. The birth of our universe was simply a physical impact in a higher dimension. And if these brains are constantly drifting, pulling apart, and colliding again over trillions of years, it means the Big Bang is not a one-time event. It is a cycle, a majestic, eternal heartbeat of the cosmos, echoing endlessly through the hidden geometry of space. Before I share the final philosophical truth of what this means for your everyday life, I want to take a brief moment. Crafting these deep, rigorous journeys into the absolute bleeding edge of theoretical physics requires an immense amount of time, research, and dedication. If you find value in having your mind stretched and your perspective permanently changed, please consider supporting this channel directly by using the Super Thanks button located just below this video. Your contribution is the actual gravitational force that keeps this project moving forward, allowing me to continue bringing these complex mysteries into the light without ever watering down the science. Now, let us bring this monumental realization back down to Earth. If the cycle of colliding brains is real, it means the history of our entire universe. From the initial fiery explosion to the birth of the first stars, to the formation of our planet, and to the very moment you are sitting here, listening to my voice is just a single fleeting spark in an infinite engine. The fundamental forces that govern the birth and death of everything we have ever known are operating in a physical space we cannot even point a finger toward. We are passengers on a three-dimensional raft, entirely blind to the vast roaring ocean moving just beneath the surface.